Hey, it's Ajay Bidyarthi here. Let's talk about how the Blackcoffer team cracked one of the trickiest problems facing modern research institutions, making sense of complex time-based data without losing your mind. So imagine you're running a research project at a big US institution. You've got data pouring in from hundreds of students, across dozens of teams, each playing in different games, over multiple academic terms. Now, you don't just want to know what's happening at one point in time. You want to track what's changing, what's staying the same, and most importantly, why those changes are happening. But here's the kicker. Traditional modeling just can't handle all this complexity. Let me explain why. First, when you measure the same people over and over, their results are naturally related. Think of a student's performance across multiple rounds. If you don't model that connection, your predictions end up totally skewed. Second, what if something that happened 2 rounds ago is still affecting scores now? That's what we call dynamic or lagged effects. Capturing that relationship is tough, but it's crucial if you want real insight. And then there's the nested structure. Students inside teams, teams inside games, games across terms. It's like Russian dolls, but with data. If you ignore these layers, you miss the bigger picture and sometimes the small but important details. So, what was the solution? Advanced Statistical Mixed Modeling. Sounds fancy, but here's what that means. We treated time not just as a number, but as something that could change differently for each student. That's random slopes in action, so we could see whose performance was rising, whose was dropping, and by how much. For immediate trends, we captured what was happening in each round. For long-term effects, we added those all-important lagged predictors, tracking how past rounds influence the future. And we put all of this inside a model that respects the hierarchy, the students, the teams, the games. Validation? Absolutely. We ran every diagnostic you can think of, checking for autocorrelation, partitioning the variance, comparing different models. We even split the analysis into 2 Jupyter notebooks, one for speed, one for depth. At the end of the day, what did the client get? Cleaned analytics-ready data in Excel and CSV, 8 sheets of results from variables and correlations to statistical tests and predictive models, plus a full methodology document, insights and recommendations, and my favorite, a Loom walkthrough showing exactly how to run the code yourself. Tech-wise, this was all done in Python, using Pandas, NumPy, SciPy, stats models, Matplotlib, and Seaborn. We leveraged Google Colab for seamless, cloud-based execution even with massive datasets. But let's talk impact. The institution can now understand with real precision how student diversity and team dynamics drive success both instantly and over time. They're making smarter decisions, optimizing strategies, and validating business assumptions, all thanks to this robust, flexible modeling approach. And the best part? The tools and methodology are scalable. As new data comes in, the model evolves, keeping insights fresh and actionable. So that's how Blackcoffer tackled a seriously complex challenge in academic research, turning tangled data into clear, actionable insights. Thanks for watching, and remember, with the right approach, even the messiest data can tell a powerful story.